Here I have loaded the two methods, factorial and power tool, that we just discussed. And you can see that these are the two methods. Let's take a look to see what would happen if we remove statics here. And here I also have written the main method, which would try to make use of the two methods that we have described. You can see that there's another while loop here so that we can test these methods on different inputs. If we compile the program, what you'll find is that it complains about the use of the factorial method because you cannot use a non-static method in main, since main is declared as statics. Well, another way to use a non-static method in a static method is to actually instantiate an object. For example, here, if we define an object t by using the new operator, then you can refer to the method factorial by using the dot operator. In this case, the method compiled. But then t here is meaningless object. So let's go back and change the method back to statics. The program compiled without any problem. Let's now try to run the program. The program asks for some input. Let's try to compute the factorial and the 2 to the n power, and these are the results. I want to illustrate that if you have 12 factorial, this is the result, which should still be correct. But once we enter a larger number, say 13 factorial, you'll find that the result here is not 13 factorial, because when you multiply 13 with this number, this would not be the correct result. Or if you try a higher number, you can see that for 14 factorial, which is supposed to be much larger than 13 factorial, but the result is obviously incorrect. And we can enter 0 here to stop the execution of the program. As you can see from here, in the main program, the condition here is to check to see whether the number is not equal to 0.